Hi, my name is Marvin H. Banyas, and today I'll be teaching you guys the integration by parts. So let's start. Integration by parts is a technique used to integrate the product of two functions. It is based on the product rule for differentiation and especially useful when the integrand is a product of a polynomial and exponential, logarithmic, or trigonometric function. So let's begin. So guys, I'll be giving you three examples on how to solve integration by parts. So first, there's a formula in integration by parts. The integration by parts is composed with the formula of the integral of u dv is equal to uv minus the integral of v du. So our first example would be the integral of xe to the power of x dx. So first, let's start by finding its u, which is x, and next is we find du, which is dx, and third we find dv is equal to e to the power of x dx. So for us to find v, if you're gonna wonder, we integrate dv or we integrate dv over, or we also integrate e to the power of x dx. So let's begin. So our u is x, du is dx, dv is equals to e to the power of x dx, and our v is equal to e to the power of x. So let's start with the formula of the integral of u dv is equal to uv minus integral of v du. So as you can see in the video, you can see the integral of xe to the power of x dx is equal to xe to the power of x minus integral ex dx. So you're going to wonder, how did we come up with that one? Or we substitute u as x and v, we substitute it as ex, and third, we substitute v is equal to ex and du is equals to dx. And last part, we solve it as x is equal to x e to the power of x minus integral of ex dx, where we integrate ex as a equal of x e squared x e to the power of x minus e to the power of x plus c. So our second example would be the integral of x cosine x dx. So what we're gonna do first is look for its u, du, dv, and v. So first, we find its u, which is x, du is dx, and we find dv is equal to cosine x dx, where the integral of cosine of, we integrate dv and cosine x dx is equal to v is equal to sine over sine x. So second example, the integral of x cosine x dx is equal to x sine x minus integral sine x dx. And by integrating the sine x dx, it would be equal to x sine x plus sine will turn into cosine x, which is the integral of sine x. So our answer is x sine x plus cosine x is plus c. And our last example would be the integral of in x dx. So first, we find its u, du, dv, and v. Our first thing we need to do is to find the u, which is the in x. And du is equal to x. And by integrating it both sides, du and x dx, or we substitute it, it would be equal to 1x. That's why we got du as 1 dx. Next would be our dv, which is dx, and the integral of dv and dx would be v is equals to x. And let's start by solving it. So the integral of in x dx is equal to x in x minus integral of x times 1 over x dx. So by bringing out x, we integrate the fraction 1x is equal to, would be the answer on the formula, u dv is equal to uv minus the integral of v du, and our answer would be x in x minus integral of 1 dx is equal to in x minus x plus c. So there you have it. Thank you guys for listening to our integration by parts. And my name is Marvin H. Banyas. Thank you.